remember what a function is? For every input, for every number that you put in for x, you get one y. Okay, so equations that represent functions are often written in function notation. Okay, so y equals 4x minus 1. Function notation looks like this. It's the same thing, except instead of writing y, we're going to write f of x. That's how you say that, f of x. Now that's not multiplication. This is exactly the same thing. This is exactly the same thing as writing y. It's just a different notation or a different form. It says f of x when you read it. Equals 4x minus 1. Sorry, 4x minus 1. So notice that these are the same. The equations are the same. The only difference here is the y is replaced with f of x. Okay, so this is read as f of x equals 4x minus 1, which you know that that's what that says. So this part right here, f of x, that's how you say this, equals, and then 4x minus 1. Okay, it's just a different notation. And when you get into higher math, this is all you're going to see is f of x, okay? But it's the same thing as y, so don't get confused. So f of x is the output, and x is the input. So just like y is the output and x is the input, f of x, we can think of this, like I said, is the same thing as y, okay? So if x was the input originally and y was the output, f of x and y, these are the same thing. F of x is the output and x is the input, okay? So function notation is especially useful for finding a value in the range that corresponds to a certain domain value. So all this says is function notation, which is this, is especially useful for finding a value in the range. Remember, range is y, so finding a y that corresponds to a certain x, okay? So it's just finding a y value when you plug in an x value. That's all that's saying. So if f of x, remember this is if y equals 4x minus 1, it's the same thing. Find f of negative 7, okay? So in this case, I'm going to erase this so I have more room, but that's the same thing as y. In this case, this is saying f of x, right? That's this piece, f of x. Notice here, what did they replace the x with? They replaced the x with a 7, a negative 7, right? This negative 7 is in place of x in f of x, right? You see that? This negative 7 is in place of x. So we're going to plug this negative 7 in for every x that we see in our equation. Okay, so this is what it's going to look like. F of negative 7 equals, every time I see an x, I'm going to plug in a negative 7. 4 times negative 7 minus 1. Why did I put 4 times negative 7? Because this says 4x. That's multiplication. 4 times, well, my x here is negative 7. X is negative 7. So plug in negative 7 and then minus 1. So I'm just substituting negative 7 in for x here. And then I just solve. Remember PEMDAS, we always do multiplication first. So if we're doing this piece, that's negative 28, and bring this down, minus 1, which is negative 29. Okay, I'm going to write it over here, negative 29. So the answer for that, when I plug in negative 7 for x, is negative 29. Okay, let's do the next one. So evaluate each function for the given value. So here, what does it tell us our x is? Our x here is 5, f of x, right? F of 5. F of x equals x plus 7. We're plugging this 5 right in for our x. So f of 5 equals 5 plus 7. Notice I plugged in x was for 5 here. I plugged in x as 5 here. I just carried the 7 down and the plus down. So that means f of 5, what is 5 plus 7? 12. So 12. 12 is our answer. Okay, 12 is our answer. What about this piece? So this piece tells us our x is, see, g of x, g of negative 3. So negative 3, we're going to substitute that in for each x that we see. G of negative 3 equals 3 times negative 3 minus 8. So g, I'm just going to say equals, we'll just go equals down. So here, that piece, we're multiplying first, PEMDAS, always PEMDAS. 3 times negative 3 is negative 9, minus 8. Whenever we have negative 9 and we're subtracting 8, we're getting smaller. So it's negative 17. We're going to add those two numbers when we have the same sign. We add them and then keep the sign. All right, let's try this next one. Okay, so here we have positive 9, h of x right here, h of 9. So this x equals 9. So we have h of 9 equals 2/3 times 9. Again, we're just plugging that 9 in for x everywhere we see x. And then minus 1, we're just bringing down that negative 1. Okay, how do I multiply fractions? Always put the number over 1 if it's not a fraction. Okay, so this equals, I'm going to move this over here because I don't really have room. So this is 2/3 times 9 over 1. We can either multiply across, or if you see that we can actually cross cancel here. So what's 3 divided by 9? So that's 1, right? But I'm just gonna, I'm sorry, that's 3. But I'm just gonna multiply across because that's what I've been doing. So 2 times 9 is 18, and 3 times 1 is 3. What's 18 divided by 3? 6, okay? So this whole piece right here, this whole piece, 2/3 times 9 over 1, that's 6. So I'm going to substitute that with 6. So this is 6 now. And then I still have that minus 1. So that's going to be 5. So our answer in that one is 5. Okay, now we're going to do some squared. So notice there's 3 x's in this one. F of x, right? But then there's an x squared and then there's a minus x. So we're going to plug in this negative 4 everywhere we see x. So f of negative 4 equals, now when I plug something into x squared, always do parentheses. It's negative 4 and that whole thing is being squared. Negative 4 squared minus, okay, again, that minus right here is part of the equation, right? So minus, and now I'm plugging in a negative 4, minus negative 4. So negative 4 squared, that's 16. Negative 4 times negative 4 is positive 16. This whole thing turns into a positive. So when we have a negative and a negative right next to each other like that, it's just going to turn into a big plus sign. So I'm going to say plus 4. And 16 plus 4 is 20. All right. So now another thing. So notice that f of 5 here, we're plugging this in for x everywhere we see x, right? Now notice this negative sign. So I'm going to bring down, I'm going to say, okay, f of 5, I'm plugging in 5 everywhere I see an x. Negative, I'm going to keep that there. But my actual 5, my actual number here is a positive. Here, up here, it was a negative. So I'm plugging in this negative, this whole thing. I plugged it in and then I put parentheses around it, right? But it was negative. Here it's positive, and I'm going to put parentheses because this is a positive 5 now, not a negative 5. Where did the negative come from? It came from the problem already. Negative x squared, right? So we're going to just bring that down and then plug in 5. And then squared. Plus 6 times 5. We're just plugging in 5 for x. Minus 4. Now, this piece, that negative drops, and we have 5 squared. So what's 5 times 5? That's 25 plus 30 minus 4. Okay, so negative 25 plus 30, that's 5. Minus 4, that's 1. Okay. We'll try number 6 and then we'll go on to the back page. Okay, so here g of negative 8, right here, g of negative 8, that means I'm plugging in negative 8 everywhere I see an x. Negative 8 equals negative 1/2 times negative 8 plus 9. So again, I see a fraction there, so I'm going to put the negative 8 over 1. Negative 1/2 times negative 8 over 1. And then I'm just going to bring down that plus 9. Now multiply across. Negative 1 times negative 8 is 8. 2 times 1 is 2. And that equals 8 divided by 2 is 4. 4 plus 9 is 13. Okay. So let's try number 9. Now look at number 9. 9's a little different. Notice, see how now we have c plus 7 for the variable. So this is what this means. We're going to plug in c plus 7 now, because it says here that our x, f of x, our x is now c plus 7. So that means everywhere I see an x, I'm going to plug in a c plus 7. So c plus 7. Actually, let me move this over just a little bit so you can see. Okay, f of c plus 7 equals. Now I see an x here, so I'm going to plug in c plus 7 where I see that x next to the 4. So 4 times c plus 7, and then I'm going to bring that plus 11 down. So all I did was substitute this in for x. Okay, c plus 7 in for x. Well, what does that look like? This piece is distributive, right? I distribute that in just like that. So that's 4c, 4 times c, plus 28 plus 11 equals 4c. And then what? I can't combine c with 28 or 11, right? They don't have c's, but these two have no c's. They have no variable. So I can add those two, and I can say plus 39, and that's it. I cannot combine anything else. Okay, let's try 10. So 10's kind of the same thing. We have that 2k minus 5, and that we're substituting that in every single time we see an x. Okay, so h of 2k minus 5 equals negative 9. I don't see an x yet. Minus, okay, here's my x right here. Now that minus came from the formula, came from that problem already. So I'm leaving the minus, but I need to put parentheses when I plug in this x, because I'm actually subtracting this whole term. So this whole thing, this entire thing, 2k minus 5, I'm subtracting that whole piece, right? Because it's minus x. Minus, this is my whole x term, so I need to subtract every piece of that. So I need to distribute here. Okay, we have negative 9. Now that's technically a 1, right? Isn't that like, that's like a negative 1, right? So I'm actually distributing that negative 1. I'm just changing the signs. So negative 1 times 2 is negative 2k. Negative 1 times negative 5 is a positive 5. Do I have any like terms here? I do. I have negative 9 and I have a positive 5, right? So negative 9 plus 5, I'm going to bring down actually I'm going to bring down this guy, because negative 2k, that doesn't have any like terms with that. But negative 9 plus 5 is negative 4, and that's it. Okay. Now, it says for questions 11 through 16, use the functions to the left. Use the functions to the left. So f of 4 plus 9. F of 4 plus 9. So I'm going to plug in, I'm going to look at f of x. Now this right here, that guy, that f right there, that tells me which function to use. That tells me, okay, I'm going to use my f of x function because I see that f there. Let's just jump down really quick to 13. You see how that says g there and that says g there? That means I'm going to be using my g formula for that. So whatever variable is in front of, like this is f of 4, that f, that tells me which function to plug it into. I'm going to plug it into my f of x. So I'm just going to write down f of x equals 8 minus 3x. This piece says plug in 4 wherever you see an x. So I'm like, okay, I'm going to plug in 4 here. 4 equals 8 minus 3. I see another x, so I'm going to plug in a 4 there. This is multiplication here, so I'm still multiplying. But I still have that plus 9. I'm going to add that to the end. Okay, this whole thing, 8 minus 3 times 4, that's just this piece, right? That's telling me plug in 4 in my f equation everywhere you see x. So I'm like, okay, 8 minus 3 times 4, and then I have that plus 9 at the end. What do we do first? We cannot do 8 minus 3. Do not do 8 minus 3 because multiplication comes first. We have to do this piece first. Okay, you'll get a different answer if you don't. So 8, I'm going to leave that there. Negative 3 times 4 is negative 12 plus 9. Okay, now I can always add and subtract left to right. I don't have to add first. You never have to add first. You can always go left to right when you're just left with addition and subtraction. So 8 minus 12 is negative 4, but I still have that plus 9. So that's 5. So that's my answer there. Okay. Let's do 13. We'll do 13 and probably 16. And then we'll move down. Okay, so g of 4. So this is telling me this piece I'm going to do in red. So let me actually erase this. Okay. This piece I'm going to do in red. So g of 4, this tells me, plug it into the g equation. So, okay, g of x, well, I'll just write g of 4. I'll plug it in right now. G of 4 equals x squared. So everywhere I see an x, I'm plugging into 4. Remember, always put parentheses. 4 squared plus 2 times 4. Great. So that's one piece. I'm going to add to that g of negative 1. So this tells me plug it into g because of this. Plug it into the g equation. Plug in negative 1. So, okay, g of negative 1 equals, remember always parentheses, negative 1 squared plus 2 times negative 1. When I solve both of these, after I solve this piece and after I solve this piece, I'm going to add them together. That's what this tells me to do, right? I'm taking g of 4 and I'm adding it to g of negative 1. So 4 squared. 4 squared is 16 plus 2 times 4 is 8. So this whole thing on this side, 16 plus 8, 24. So my g of 4, that's 24. I'm not going to box it because I need to add it. I need to add it to whatever's over here. Okay, so let's solve this piece. Negative 1 squared is positive 1. Negative 1 times negative 1. And then a positive 2 times a negative 1 is negative 2. Well, 1 minus 2, that's negative 1. And I'm going to combine both of these, right? What's 24 plus negative 1? That's 23. So my answer here is, right over here, 23 for 13. Okay, let's try a fraction one. So, okay, now this one's a little different. Let's look at this. So this one says h of x equals 39. So I'm going to write down my equation. H of x equals negative 5 over 2x minus 1. Okay. So it tells me this time, look how this is different. This over here was saying like g of 4, g of negative 1, right? They have the numbers next to the G, or next to the F, right? We have that 4 right there. But in this case, they don't have a number here for the x, so we don't plug anything into this x. It's actually telling us our h of x, or this right here, this guy, our h of x is 39. So I'm going to substitute 39 in for here, because they tell me this time h of x equals 39. So negative 5 over 2x minus 1. This time it tells me find x, right? Find x. So I'm actually finding this time. Okay, now actually I'm going to rewrite this up here. There's not very much room here. So another fraction, but don't freak out. So what's the first step we do here? Can we collect like terms? This has no x, this whole thing has an x, and this has no x. So I'm going to collect the two that have no x, right? I need to get this guy and this guy together because they both are the same. They don't have any x's. So I'm going to add 1 to this side. That way, my x is by itself on this side. I have my whole x term over here. And then I have my numbers on one side. So 39 plus 1 is 40 equals negative 5 over 2x. Now, how do I get rid of a fraction? This is whenever I see negative 5 over 2 and it's multiplied to an x, like a fraction that's multiplied to an x, I can multiply it by the reciprocal, right? So if I multiply, what's the reciprocal of negative 5 over 2, or the flip of the fraction? Negative 2 over 5. So I'm going to multiply by negative 2 over 5 to both sides. That cancels. We have x left on this side. Now, to multiply fractions, I'm just going to put this over 1. Well, if I multiply across, what's negative 2 times 40? That's negative 80. 5 times 1 is 5. And negative 80 divided by 5, if you put that in your calculator, it's going to be negative 16. So that's your answer. Negative 16 is x for this one. Okay, so why don't we try number 15 together too? Here, f of x again. F of x equals negative 13, so look at the difference here compared to that, right? So it tells us this time to actually find x. So this tells me plug it into my f of x equation. So it's 8 minus 3x, that's my f of x. But what does it tell me that f of x is? Negative 13. So I'm going to say, okay, negative 13 is where I'm plugging this negative 13 in for f of x. 8 minus 3x. Now, again, this is just an equation. So how do I get, this has no x. I'm sorry, that does have an x. This has an x, this has no x, and this has no x. So I need to move the 8 and the negative 13 together. Whenever I cross the equal sign, I do the opposite. So I'm subtracting 8. Negative 13 minus 8, I'm adding those two. So it's negative 21 equals negative 3x. Bring that up here. Negative 21 equals negative 3x. Divide each side by negative 3, and x equals 7. Okay. We're going to do the application one together as a class, but let's look at 18 really quick. So it says, given the graph of f of x. So remember, f of x is the same thing as y. We can always substitute that for y. Given the graph of y, or f of x, this is just our function, right? It's just saying this is a function. Find each value of the function. So it says find f of negative 3. Remember when they give us f of negative 3, this is like f of x. What are they telling us x equals in this case? They're telling us x equals negative 3. So they're saying find the y when x equals negative 3. Okay, so x equals negative 3. So we're going to go negative 3, and we're trying to find the y from that point. So here's my negative 3 for x. 1, 2, 3. That's negative 3 for x, right? That's right here. That's at negative 3. Find y. Okay, well, at negative 3, where does the y hit? Where does this graph hit? It hits at 2, right there, right? Positive 2. So my answer for this is 2. Okay, now here for this one, this is saying x, again, f of x. This is saying x equals 1. So when x equals 1, here's my x equals 1. This is 0, 0, right? So this is x equals 1. When x equals 1, what is y? Y is 2 again, right? Y is 2. Okay, so again, f of x. What is it saying x is in this case? It's saying x is 0. So when x is 0, what's y? Well, I'm going to trace back up to my graph up here. What's this point up here for y? 1, 2, 3, 4, 5. So y is 5. F of x is 5 when x is 0. That's all that's saying. Okay, f of x. So when x is 2, 1, 2, what is y? Well, 1, 2, 3. It hits it right here. So y is a negative 3. Okay? All right, last one. So f of negative 4. Again, this is saying f of x. So when x is negative 4, 1, 2, 3, 4, what is y? Y is 1, 2. This is where my graph meets at negative 4, 2. So positive 2. What about at 0? When x is 0, y is 0. It's right there. The point is right at the origin. What about this one when f of x, when x equals 2, right here, y is negative 2. So negative 2. And last one, when x here, it says x is 5, f of 5, that just means x is 5. What is y? So if we count over 5 on the x, y here is right here, y is negative 1.